The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope you all are doing good. You must be busy preparing for your online exam. Do not get panicked, children, because as sir told, it is for the teachers to understand how far our teachings have reached you. You are able to go on with the syllabus, or is there any area that you are finding it difficult? So this is the only way that we can understand our method of teaching and how it has been helping you. So with that, we will start with today's class. Last class we were learning about ammonia preparation and also about reversible irreversible reaction, and also we learnt about properties of ammonia. So today's class will be dealing with a very sensitive topic which is playing a very vital role as for this lesson is concerned, and it is chemical equilibrium. We have been hearing this word equilibrium for a long time, right? Chemical equilibrium means the equilibrium which are taking place in chemical reactions. So you can observe this graph. There is a graph plotted between rate of chemical reaction and time. When I say rate of chemical reaction, it is nothing but how fast or what is the speed of the chemical reaction that is taking place. And I am very sure that these will be considered only for reversible reactions. I repeat again, only for reversible reactions we will take this into consideration. So if I am going to draw a graph between rate of chemical reaction and time, I get a curve like this where you can see curve B representing forward reaction, curve C representing backward reaction, and there is a point A where both these reactions curves meet each other. Right, I have marked that point of intersection as A. Now there are some questions which are asked in textbook. You can take page number 85. After observing the graph, please let me know what happens to the rate of forward and backward reaction as the time progresses. As the time starts moving, there will be a particular situation where the rate of forward and backward reaction becomes equal. They tend to become the same, that is they remain constant. Such a point is A, which we call it as equilibrium. So you can write as time progresses, rate of forward and backward reaction becomes equal. Please write it, children. The second question is identify the point at which rates of both forward and backward reaction becomes equal. So here there is a point of intersection meeting, that is A, at which rate of forward and backward reaction becomes equal. So the answer is point A. So from this, what do you understand? The stage at which this has been now rubbed, okay. The stage at which rate of forward reaction becomes equal to rate of backward reaction in a reversible reaction is called as chemical equilibrium. So what is chemical equilibrium? The point, the stage, the intersection at which the rate of forward reaction will be equal to the rate of backward reaction. Where does it take place? In a reversible chemical reaction. So in a reversible chemical reaction, there is a point or there is a stage at which the rate of forward reaction becomes equal to rate of backward reaction. Such a stage we call it as chemical equilibrium. There are some characteristic features for a chemical equilibrium. There are four important postulates. The first one is At equilibrium, both the reactants and the products coexist. So when I say coexist, it's nothing but at equilibrium the reactants are also there, the products are also there. They are dependent on each other. At equilibrium, rate of forward reaction becomes equal to rate of backward reaction. That we already saw in the graph. It is dynamic at the molecular level. What do you mean by dynamic? Keeps on moving. The reactant starts getting converted to products. The product starts converting to my reactants. Next, it is attained in closed system. Only in a closed system there will be reversible reaction taking place. If it's an open system, the reactants will get converted to the products, but the products cannot give back my reactants. So definitely in a closed system only chemical equilibrium will be attained. So these are the four main postulates of chemical equilibrium. With this, we will be studying about Le Chatelier's principle and then factors affecting it. Dynamic equilibrium. Most reactions which occur in a closed vessel remain incomplete under a given set of conditions of temperature and pressure. Let us now consider a reaction in which reactant X changes to product Y. Initially, the reaction begins only with the reactant as the reaction mixture. As the reaction progresses, the reactant changes to the product Y. The concentration of the reactant X in the reaction mixture decreases and the concentration of the product Y increases. The reaction progresses further with a continuous increase in the concentration of product Y and decrease in the concentration of reactant X. Finally, an equilibrium state is reached, which is a point at which there is no further change in the concentration of the reactant and the concentration of the product. Thus, there is no change taking place in the equilibrium state. Does the reaction stop completely? To answer this, let us study a chemical reaction between hydrogen and iodine. Consider a chemical reaction between hydrogen gas and iodine gas which takes place at a constant temperature in a closed container and leads to the formation of hydrogen iodide. In the initial stage of the reaction mixture consists of only the reactants which are the colorless hydrogen gas and violet iodine gas. Hence, the color of the reaction mixture is deep violet. As the reaction progresses, the molecules of hydrogen and iodine collide with each other, thereby resulting in the formation of molecules of product, namely hydrogen iodide. Such reaction, which leads to the formation of product, is called forward reaction. As the reaction progresses, the concentration of the reactant decreases and the concentration of the product increases. Since the reaction occurs in a closed container, there is a tendency for the hydrogen iodide molecules to convert back into hydrogen and iodine molecules. This reaction, which proceeds leading to the formation of reactants by the decomposition of the product HI, is called backward reaction. This implies the reaction between hydrogen and iodine occurs in both the direction and it is reversible in nature. The graph for the concentration of reactants and products against time shows that there is a decrease in concentration of the reactant and decrease in the rate of forward reaction, and an increase in the concentration of the product
and an increase in the rate of backward reaction. There is a certain point where the rate of forward reaction is equal to the rate of backward reaction. This point is called equilibrium point or equilibrium stage. At equilibrium, the concentration of the reactants and the concentration of the products becomes constant. However, in reality, at molecular level, forward reaction which leads to the formation of HI and the decomposition of HI which leads to the formation of hydrogen and iodine continues at equal state. This is called as dynamic equilibrium. Dynamic means moving, which refers to continuation, in which the two opposing reactions are continuing even after the equilibrium is established. Here is a summary for you.
We will see Le-Chatelier's principle, the most important principle in chemical reaction or chemical equilibrium, which you will be studying continuously even for higher classes. What does this say? When the concentration, pressure or temperature of a system, when the concentration, pressure or temperature of a system at equilibrium is changed, a reaction, a reversible reaction has already attained equilibrium, and if I am going to change its concentration, pressure or temperature, what will happen? The system will readjust. The system will try to readjust itself so as to nullify the effect that change has happened. To nullify means to balance the change that has happened and attain a new state of equilibrium. When there is more concentration, when there is more temperature, when there is more pressure, what happens? The system will adjust so that the increase in pressure becomes less, the increase in temperature is balanced, the increase in concentration is reduced. How does it work? Let us see. There are some factors which are affecting the chemical equilibrium. There are concentration, the second one is pressure, third one is temperature, and fourth one is catalyst. Concentration, pressure, temperature, catalyst. So let us focus on concentration. Now concentration can be dilute or it can be concentrated. So how it is going to affect the chemical equilibrium? Let us see. Take an example, nitrogen combines with hydrogen to give ammonia. So this is my reversible reaction, because I told you chemical equilibrium will take place only in a reversible reaction. So if I am going to increase the concentration of nitrogen, assume I am going to add more and more of nitrogen, what will happen? This equilibrium is disturbed. According to the principle, what will happen? The system has to readjust itself. How it will readjust? To decrease the concentration of nitrogen. Nitrogen is more. I want to reduce nitrogen. So what should I do? I should make sure that it will combine with more and more hydrogen to give ammonia. So if I increase the concentration of nitrogen, I should make sure that the forward reaction take place so that a new equilibrium is achieved. Are you able to follow, children? I have A plus B giving C. If I have more of A, this is already attained equilibrium. Now reactants and products are equal. If I add more A, the system is disturbed. So what should I do? I should reduce the concentration of A. To reduce the concentration of A should be giving C, more and more C, so that the system will attain a new equilibrium. So you should always remember, when there is an increase in concentration of reactant, it will be forward reaction. When my reactant concentration is more, it will be forward reaction. If there is an increase in concentration of product, if product is more, it will be backward reaction. You are able to understand? increase in concentration of reactant will be forward reaction. But if the reactant concentration is decreased, what will happen? I have less number of reactants. So which reaction will take place, forward or backward? Backward, because I need more of reactants. So increase in concentration of reactant, forward reaction. Decrease in concentration of reactant will be backward reaction, so that I get my reactants. If the product concentration is more, it is backward reaction. If the product concentration is less, it will be forward reaction. So there is a table given to you and some questions asked. Nitrogen and hydrogen gives ammonia, page number 86. The rate of which reaction increases when the concentration of nitrogen is increased? Forward or backward? Forward reaction. Please put a tick there. What will happen if the concentration of ammonia is increased? That is, product is increased. It is backward reaction. Right there, children, backward reaction. And the next one, what will be the effect if ammonia produced is removed continuously? Ammonia is formed and removing. Ammonia is formed and removing. So what will happen? Only forward reaction will take place. Forward reaction will be continuing because I need ammonia to be formed in the product. So forward reaction occurs. There is a table given to you. Action, change of concentration, change in rate. Let us discuss that now. More hydrogen is added. Increase in concentration of reactant. So what happens? Rate of forward reaction increases. More reactant, forward reaction. Second one is more ammonia is added. That is increase in concentration of product. So what will happen in change in rate? Rate of backward reaction increases. Please write, rate of backward reaction increases. The next one is ammonia is removed. If ammonia is removed, what will happen? Forward reaction occurs. So rate of forward reaction increases. Third one. Last one, more nitrogen is added. That is, reactant concentration is more. So again, forward reaction increases. Have you written, children? So this can be asked in your exam with different examples, not only the same one, nitrogen and hydrogen. So you should just understand, if reactant concentration is more, forward reaction. If product concentration is more, backward reaction. This is the basic thing that you should be knowing in influence of concentration. Now we will learn pressure and chemical equilibrium. Pressure and chemical equilibrium. You just observe this reaction. Nitrogen combining with hydrogen to give ammonia. Now what is asked? Please keep your book ready and understand each and every question. In this equation, what is the total number of moles of reactant molecules? We know with whatever number we multiply the reactants or products, that is the number of moles. So in my reactant molecules, I have 1 mole of nitrogen combining with 3 mole of hydrogen. So 1 plus 3 will be 4 mole of reactant molecules. What about my product? It is asked, what about the products? Products I have only 2 moles. So here I have 4 moles of reactants, here 2 moles of products. So what is given here? 4 mole of reactant molecules react to give 2 moles of products. That is my forward reaction. In my forward reaction, 4 moles of reactant molecules react to give 2 moles of my product. But what happens in backward reaction? In backward reaction, 2 moles of my product react to give my 4 moles of my reactant. So that you can write in the backward reaction. In a gaseous system, decrease in number of moles help to decrease the pressure. What do you mean by that? For that, we will get back to our second chapter. Boyle's law states pressure is inversely proportional to volume, which means when pressure increases, volume decreases, or when pressure decreases, volume increases. They are inversely proportional. But what is Avogadro law stating? Avogadro law states volume is directly proportional to number of molecules, which means when volume increases, number of molecules increases. When volume decreases, number of molecules decreases. So if I want my decrease in pressure, the volume will increase, so number of molecules will also increase. So reaction will move in the direction in which side there is more number of molecules. When there is an increase in pressure, when the pressure increases, the volume decreases, so number of molecule decreases. So what happens in an equilibrium system, when there is an increase in pressure, system is affected, volume is decreased, number of molecules will also decrease, so the system will move in the direction where there is less number of molecules. So what is asked in your textbook, let us answer those questions. According to Le-Chatelier principle, when pressure of a system is increased, it will try to attain by reducing the pressure. So how I can reduce my pressure, we will see. In the manufacture of ammonia, the reaction in which direction results in decrease in number of molecules? Forward direction, 4 is giving 2. In backward direction, 2 is giving 4. So in which side you have less number of molecules? Only in the forward direction. So you will write forward reaction. Please write forward reaction because 4 moles is giving 2 moles of products, which is less number of molecules. Next question, what happens when the pressure of the system is increased? When pressure is increased, volume decreases. Please write there, volume of the system decreases, number of molecules decreases. What happens if the pressure of the system is decreased? Volume will increase, number of molecules will also increase. So what will, which side it will move? It will move in the backward direction. Okay. Now last question, in the manufacture of ammonia, why a high pressure is used? See, in the manufacture of ammonia, when I say manufacture of ammonia, ammonia has to be formed. So when there is an increase in pressure, the volume decreases. When the volume decreases, number of molecule decreases. So in the forward direction only I have less number of molecules formed. So I want my forward direction to take place so that ammonia is formed more and more. That's why I increase the pressure. When there is an increase in pressure, the volume decreases, number of molecule decreases, system will move in the forward direction. You are able to follow, children? Okay. Now next one is analyze the chemical equation where H2 plus I2 is giving 2HI. So all are in gaseous state. What is the total number of moles of reactants? I have 1, so total it is 2. What about the products? Products, reactants are 2, products are also 2. So when number of moles of reactants is equal to number of moles of products, what will happen? There will be no change in the pressure. That is, the effect of pressure will be nil. There can be no effect of pressure in a reversible reaction where the number of moles of reactants are equal to the number of moles of products. I hope you are able to follow, children. In a reversible reaction, if there is no change in the number of gaseous molecules in the reactants and product side, pressure will not have any effect in the chemical equilibrium. I hope you are able to understand this. Whatever notes are given in the box, please write it. Now we'll just get back into temperature and catalyst. With that, we'll stop for today. We have come to the last part of today's class, effect of temperature on chemical equilibrium. Same equation, nitrogen combines with hydrogen to give ammonia, and you can see some of the heat is being released along with the formation of ammonia. See, we have already learned that there are two types of reactions, exothermic and endothermic. When I say exo, means giving out of heat. When I say endo, it means absorption of heat. So in this equation, now assume that if I am going to increase the temperature, when I am going to increase the temperature, what will happen? System has to adjust in such a way that the increased temperature should be absorbed. It should be taken inside. So when there is an absorption of heat, definitely it is an endothermic reaction. Now if you see here, the forward reaction is exothermic because heat is given out. The backward reaction is endothermic because heat is being absorbed. So if in the system, if I am going to increase the temperature, it will be backward reaction that is taking place, which is endothermic reaction. And in the same reaction, if I am going to decrease the temperature, system will make sure that there are some temperature which is being increased, or there is an evolution of heat. So there will be forward reaction that is taking place, which is an exothermic reaction. You should definitely read the textbook, children, because more explanation is given to you, and I will be putting video also to understand the exo and endothermic reaction. And for the manufacture of ammonia, as I told you, high pressure is required. Temperature should be very low, which is around 450 degrees Celsius. Low temperature, high pressure condition is considered for the production of ammonia. Next one is catalyst. Catalyst play a very important role. When I say catalyst, any normal reaction taking place, to alter the reaction, that is to increase or to decrease the rate of reaction, we add catalyst. Catalyst can be a positive catalyst and also a negative catalyst. When I say positive catalyst, it increases the rate of reaction. When I say negative catalyst, it decreases the rate of reaction. Assume children, there is a reaction where equilibrium has achieved already. So if I am going to add a catalyst, that will affect in both the directions. I cannot make sure that it will affect only in one direction, because for a catalyst, whether it is a forward reaction or a backward reaction, it is the same. So in simple words, I will say catalyst has no role in the chemical equilibrium. If an equilibrium has achieved, there is no point in adjusting the catalyst. That's why in Le Chatelier's principle, we mention only concentration, pressure and temperature. I hope you have understood with today's class chemical equilibrium, Le Chatelier's principle, effect of concentration, pressure, temperature and catalyst. With this, we'll wind up the class for today. Watch the videos. If you have any doubt, kindly ask me, children. Okay? Wish you good luck for your exam. I know all my children will do well. Do not get panic. Understand and then answer the question. Okay? So see you in the next class. Until then, take care. Bye.
Le Chatelier's principle. At the equilibrium state of a reaction, the concentration of the reactants and products is constant at a particular temperature and pressure. But, however, have you ever wondered about the effect of change in concentration, pressure or temperature having on the process at equilibrium? Le Chatelier in 1884 was a person who was discussing about the effect of concentration, temperature and pressure in a system at equilibrium, what happens to the change. According to Le Chatelier's principle, a change in concentration, pressure or temperature in a system at equilibrium will shift the equilibrium in the direction in which the effect of the increased factor is reduced or consumed. Let us see the effect of concentration, pressure and temperature. According to Le Chatelier principle, when the concentration of any reactant or product is changed at the equilibrium point, the equilibrium will shift in the direction in which the concentration of the added component is consumed or it is reduced. So, to understand the effect of concentration, let us take the following example. We have potassium thiocyanate and ferric nitrate solution. When a few drops of potassium thiocyanate solution is added into ferric nitrate solution, the yellow color of the ferric nitrate solution changes to reddish brown due to the formation of thiocyanate 3 complex ion. The color of the solution continues to deepen till the equilibrium state is achieved. At this point, the color of the mixture becomes constant. Now, the equilibrium can be shifted to any direction depending on whether the reactant or the products are formed. Now, at this point of equilibrium, if the concentration of thiocyanate ion is increased by adding the reactant potassium thiocyanate, then you can see drops of potassium thiocyanate being added into the solution again to increase its concentration. The equilibrium will shift towards the forward direction, giving more thiocyanate 3 complex ion. That is evident with the darkening of the color of the reaction mixture. On the other hand, if the complex of thiocyanate 3 ion is increased by adding potassium ferrothiosulfato ions, then equilibrium will shift in backward direction by giving more ferric and thiocyanato ions. This is evident by the fading of the color of the reaction mixture, where the equilibrium will shift in the opposite direction. So, we understood that equilibrium shift towards the forward direction and also towards the backward direction. So, whenever there is an increase in the concentration of the reactant or the concentration of the product, the equilibrium will shift in the direction according to the concentration of the reactant and the product. Now, let us study the effect of pressure according to Le Chatelier's principle. According to Le Chatelier's principle, if there is an increase or decrease in pressure, the system will shift in the direction according to the fewer number of molecules. When the pressure of a gaseous reaction mixture at equilibrium point is increased, as we know, the equilibrium will shift in the direction in which the effect of increased pressure is reduced. According to Boyle's law, pressure is inversely proportional to volume. Hence, an increase in pressure will decrease the volume, thereby decreasing the number of molecules according to Avogadro's law. So, an increase in pressure will make the equilibrium shift in the direction in which there is a decrease in the volume or fewer moles of gaseous species are present. Now, let us study the effect of pressure by considering the following example. Taken a reaction between nitrogen and hydrogen forming ammonia, where 1 mole of nitrogen combines with 3 mole of hydrogen to give 2 moles of ammonia. The reactants and products are equilibrium at certain pressure. If the pressure is increased, the volume of the reacting mixture decreases, thereby the number of moles also decreases according to Avogadro's law. Now, in this equilibrium state, we can see in the product side we have 2 moles of ammonia, and in the reactant side we have 3 moles of hydrogen and 1 mole of nitrogen, together 4 moles of reacting molecules. So, the equilibrium will shift in the direction where there are fewer number of molecules. Hence, in the product side we have 2 ammonia molecules formed. So, the reaction will shift in the forward direction. So, let us summarize the effect of pressure. Increase in pressure, equilibrium shifting towards fewer gaseous molecules, and decrease in pressure, equilibrium shifting towards more gaseous molecules. According to Le Chatelier's principle, when the temperature of a reaction mixture at the equilibrium point is increased, the equilibrium will shift in the direction in which there is an absorption of heat. When the temperature of a reaction mixture at the equilibrium point is decreased, the equilibrium will shift in the direction in which there is a formation of heat. Let us consider the dimerization reaction of nitrogen dioxide, which leads to the formation of dinitrogen tetroxide. The color of the reaction mixture, which is collected in a test tube, is kept in a beaker filled with water at room temperature, is reddish brown due to the presence of nitrogen dioxide. Thus, at equilibrium, reddish brown nitrogen dioxide and colorless dinitrogen tetroxide molecules are present. Now, take two more beakers. In the first beaker, take ice water, and in the second beaker, take boiling water. Place the test tube containing the reaction mixture at equilibrium in each beaker and see what happens. When the test tube is placed in ice water, mixture turns lighter. The reaction is exothermic in the forward direction. That is, the equilibrium shifts in the direction of formation of dinitrogen tetroxide, which is colorless. When the test tube is placed in boiling water, the color turns darker. That is, the reaction is endothermic in the backward direction. Therefore, on increasing the temperature, the equilibrium shifts in the formation of reddish brown nitrogen dioxide. Therefore, increase in temperature, equilibrium shift towards endothermic reaction, and decrease in temperature, the equilibrium will shift towards the exothermic reaction, which is the evolution of heat.